Hey everyone, welcome. Today, we're going to get into something that is just the absolute bedrock of being a Java developer, traversal. You know, whether you're wrangling arrays or picking apart strings, knowing how to move through that data efficiently is, well, it's everything. So let's just dive right in. Okay, let's get real for a second. Picture this. You're in a coding interview. The pressure's on. Out of all the complex algorithms and data structures they could throw at you, what do you think is the single most tested skill? What's the one thing that comes up again and again? You guessed it, it's not about some obscure, once-in-a-lifetime algorithm. It's about a rock-solid, deep understanding of the fundamentals. And right at the heart of those fundamentals is traversal, the way you choose to loop through data. It tells an interviewer so much about how you think and how strong your foundation really is. So let's start with the OG, the classic tool in the kit, the indexed for loop. I want you to think of this as your trusty manual wrench. You know, it might not be the fanciest or the quickest tool, but it gives you precise, total control over every single nut and bolt. Every single classic for loop you'll ever write boils down to these three parts. It's a simple recipe. First, you initialize your counter. We almost always start with int I equals 0. Second, you set the stopping point, the condition. Like, keep going as long as I is less than the array's length. And finally, you tell it how to move forward, the increment, I++. That's it. Simple, powerful, and totally predictable. Now, when we apply that loop, there's a small but really important difference between arrays and strings. For an array, you get an element using square brackets, right? Array I. But a string is an object, so you have to use a method, .charAt I. It's a tiny syntax difference that can trip people up, but it's crucial to get it right every time. So when do you reach for this manual wrench? It all comes down to one word, control. You use it when you actually need the index I itself, maybe to do some other calculation. Or what if you have to go backwards? Or maybe you need to change the array while you're looping through it. In any of those cases, this is your tool. It gives you the most flexibility, period. Okay, so we've got our manual wrench. Now let's talk about the power tools. Modern Java gives us some slicker, often way more readable ways to do the same job. Let's look at the for each loop and the game changer, Java 8 streams. The for each loop is all about making your code cleaner and easier to read. It basically hides all that index stuff, the I equals 0, the I++. You stop telling Java how to get the next item, and you just focus on what you want to do with each item. This makes your code so much more expressive and, honestly, a lot harder to mess up with those off-by-one errors. And here's what it looks like. For an array of integers, it's just beautiful, right? For int element array. Simple. Now, for a string, there's one extra step you got to remember. You can't just loop over a string directly. You have to convert it to an array of characters first, using two-character array. Super common, you'll see this pattern everywhere. And then there are streams. If the for each loop was a power drill, streams are like a full-on assembly line. This is a totally different way of thinking. It's declarative. You're not writing a loop, you're building a pipeline of operations. You just describe what you want done. Filter this, transform that, collect the results, and Java figures out the how. For strings, .chars is your entry point, giving you a stream of characters to work with. Incredibly powerful stuff. All right, so we've got these awesome new power tools, so they're always better, right? Always faster? Well, not so fast. A really good developer knows the limits of their tools, and that means we need to talk about performance and the common traps people fall into. So let's ask a simple question. Let's say all you're doing is a single straight line pass through a list. No fancy stuff. What do you think is actually faster? The old school manual for loop or the elegant modern stream? And the results might just surprise you. For these simple jobs, the classic for loop is almost always the fastest. Why is that? Well, streams have what we call overhead. They have to do a bunch of setup work to create that pipeline. Now, for a really complex chain of operations, that setup pays off. But for a quick, simple traversal, that overhead actually makes them the slowest of the bunch. And here are some classic traps you have to watch out for. Number one, the off-by-one error. Accidentally typing less than or equal to instead of less than in your loop condition. We've all done it. Number two, forgetting to check if your array or string is null before you try to loop over it. That's a one-way ticket to a null pointer exception. And here's a subtle one. If you're using a for each loop with primitives like int, that loop variable is just a copy. Changing it does absolutely nothing to the original array. So let's tie all of this together. How do you take this knowledge and use it to just crush your next coding interview? Because getting the code to work is only half the battle. The other half is explaining why you made the choices you did. Think of this table as your ultimate cheat sheet. It's your decision-making guide. Do you need the index? Classic loop, no question. Is readability for a simple pass your top priority? For each is your friend. Are you chaining a bunch of operations together? A stream is probably the cleanest, most elegant solution. Knowing this table is like knowing exactly which tool to grab for any job. And in that interview, these are the talking points that show you're not just a beginner. You can mention that strings are immutable, so building them in a loop is inefficient, which is why we have String Builder. You can casually point out the limits of for each, I can't use it here because I need to go in reverse. And you can explain why you chose a simple loop over a stream for performance reasons. That's next level stuff. So imagine the interviewer asks you this, point blank, this is your chance to shine. You don't just give one answer, you give a whole masterclass. You say, well, there are 3 main scenarios: when I need the element's index, when I need to iterate backwards, or when I need to modify the collection as I go. Bam! You've just demonstrated a deep, practical understanding. And that's the real takeaway here. Writing code that works is the minimum requirement. Great engineers, the ones who get hired, write thoughtful code. They choose the right tool for the job, and more importantly, they can explain the why. They can talk about the trade-offs between performance, readability, and control. That's the skill that truly matters. So you've got a fantastic handle on the how of traversal now. But this opens up a whole new, fascinating question, which is about the what. Why is walking through an array list a totally different beast than walking through a linked list under the hood? That's the next step in your journey, but for now, keep practicing, keep questioning, and keep digging deeper.